how to make a hollow yet lightweight and strong castings using Matrix Dryve polymer modified gypsum system. Now in today's video we're going to use the Matrix Dryve to create a hollow and lightweight yet strong casting. For this video today we're going to be using a Rebound 25 brush on mold. This is a platinum silicone, so we don't need to use a release agent when casting the Matrix Dryve in this mold. But something I wanted to point out to the support shell for this mold is also made out of the Matrix Dryve, making it strong yet lightweight support shell material. Now, our project today does have several goals that we're trying to achieve. Of course, the first goal is to create a strong yet hollow and lightweight casting using the Matrix Dryve. We also want to show you how to use an alternative material to resin to do hollow castings, as well as how hollow castings can reduce the cost of the material that you're using for a project versus casting them solid. Now, let's just jump into this project and see how it's done. As mentioned, we're using the Matrix Dryve, and with that we're also going to be using the accelerator for the product, as well as some other additives like a thickener and glass fibers to make our hollow yet lightweight and strong casting out of this material. The Matrix Dryve is a all-powder polymer modified gypsum system that is much stronger when compared to regular gypsum products. Now, this is an all-powder alternative to our regular Duo Matrix Neo, which is a powder and a liquid polymer system. The Matrix Dryve has the highest flame rating for indoor and public spaces. We will be using an accurate gram scale to bring all the components for this rotocasting project together. The Matrix Dryve mix ratio can be either measured by volume or by weight. If you're measuring by volume, the mix ratio is going to be 3 parts of powder to 1 part of water, again by volume. If you're measuring out by weight using a gram scale, it's going to be 100 parts of powder to 27 parts of water by weight, again using a gram scale. Now, the reason why we want to use a gram scale is because we're adding other components like the accelerator and the thickeners to this, and we want to know exactly how much product we can add to achieve certain work and cure times. We're also going to be using the Matrix accelerator, and for that we do need to make a water accelerator solution, and I will demonstrate that a little bit later in the video. To achieve an accurate working time or pot life and demold time for your project, it's important to use the prescribed quantities to be added to your mixture so that you have a better understanding of what kind of work time, pot life, and demold time you can expect. If you have a support shell that is made out of a rigid material and has some porosity to itself, it's a good habit to seal the inside to make sure that any kind of leaked casting material will not bond to the inside of the support shell. Here I'm using some sonite wax that I will brush to the inside surfaces. Any leaked material that leaked inside the support shell and bonded to it will create uneven spots in any future casting coming out of that mold. So it's a good practice preventing that from happening. If you do apply the sonite wax to the inside of your support shell, make sure to follow the instructions for the sonite wax and allow it 20 minutes to dry before proceeding on to casting into the mold. As mentioned, I'm first going to show you how to mix the accelerator solution by adding 480 grams of water. This is room temperature water. And then we're going to add 80 grams of the accelerator powder to the water. It's important to use a gram scale here to be absolute correct on the amounts and quantities that we're dispensing. Mix the powder in thoroughly until the powder dissolves. Once the accelerator is pre-mixed, we can go ahead and start dispensing the Matrix Dryve powder. Again, I'm using a gram scale to be very exact. And same thing for the water. Again, the mix ratio by weight is 100 parts for the powder to 27 parts of water, room temperature again. To achieve a working time of 8 minutes, I'm going to be using the accelerator at 1.5% of the total weight of the powder. So 1.5% of the weight of powder is added as accelerator. I'm dispensing a very small amount of the accelerator, so I'm using an eyedropper to be accurate to add the accelerator to the water in the right quantity. Remember, these are small amounts, so the accuracy is really important. For the first layer, I dispensed 400 grams of the matrix powder, 108 grams of water, and 6 grams of the matrix accelerator. These three components are now blended together using a variable speed drill with a paddle mixer that you can purchase online. Now, whenever you're mixing powders and liquids together, it's always recommended to sift the powder into the liquid as you're mixing it. This will prevent the powder component from clumping up in the mixing process that would potentially then end up as unmixed material in your casting. And I'm going to tilt my cup to completely submerge that mixing head in the liquid. The reason why we tilt the cup when mixing product like this is so that all the material can flow into one corner, be mass concentrated there, so we have a large quantity of it, and that way also be able to submerge the entire mixer into the material and mix the material thoroughly. As always, when mixing components together, scrape the side and scrape the bottom of your mixing container. This will prevent the unmixed material that's clinging to the walls of your mixing container from ending up in your casting when you're pouring the material into your mold. So scrape the sides, scrape the bottom of your mixing container. Now, once the material is mixed, we can go ahead and pour it into our mold. And here I am making sure to get a coating of the Dryve on the entire opening of the mold. This is going to be the base when it's finished. And then I'm going to bring some of that Dryve, the casting material, to the edge and spill it right over the edge, making sure that we coat the entire inside of our mold, including the bottom or the opening of the mold. Remember, this is going to become the base of our casting once it's finished. After that, we're going to continue to spin the mold in a 360-degree fashion, making sure that the material is spread evenly throughout the mold on the inside and no surfaces are left uncoated. Here it becomes very obvious where the benefit of the accelerator comes in. Instead of having to handle the mold for 20 minutes, that's the Matrix Dryve's working time, we now have to handle the mold for only 8 minutes, saving ourselves some work and, more importantly, saving ourselves from having to handle the mold. Remember, no matter how light the mold is, once you add the weight of the mold, support shell, and the casting material, it can become very heavy to handle the product for extended periods of time. After that, we're going to set the mold upside down, allowing any of the unset material to make its way down and out of the mold. This will ensure that we don't create thick areas in one part of the casting and thin sections in another. Rather, an equal casting thickness throughout is what we're aiming for. The material is now allowed a partial cure for 20 minutes. Just like in brush-on mold making, the first layer of your rotational casting is the most important layer. That's where you capture the detail, and you don't want to have sections inside your mold that are not covered with the first layer of casting material. This could potentially cause blemishes in your final casting or consider your casting useless and a failure. So always take a look inside your mold if possible and make sure that you have a good coverage of the entire inside with the first layer of material. For the second layer, we're going to dispense the same quantities of materials as we did previously. 400 grams of matrix powder, 108 grams of water, and 6 grams of the matrix accelerator. The 3 components are now combined together in a mixing container, and as always, sift the powder into your liquids while mixing them together. Once the batch is mixed, we can pour it into the mold, and then we're going to continue the rotational casting process. Again, you want to make sure that you spin the mold in a 360-degree fashion so that the material spreads everywhere inside the mold. And yes, there will be a little bit of material that leaks out of the mold. You want to purposely bring it to the edge and make sure that it coats the inside of the mold evenly. The recommended casting thickness for the Matrix Dryve is 3/8 of an inch or 1 centimeter. That will be the thickness that we're aiming for when creating our hollow casting. And again, I'm letting the mold sit now with the opening downwards on a popcorn bucket to allow any of the liquid material still to make its way down and out. Again, creating an equal thickness throughout our casting. The material is now allowed a partial cure for 20 minutes. The technical bulletin does have a section on the rotocasting of the Matrix Dryve. And in that section, you're going to find some very helpful information that you need to consider when rotationally casting the Matrix Dryve. Our casting, the hollow casting that we're making, should be about 3/8 of an inch thick. Now, in order to minimize how many layers we have to apply to our casting and how many times we have to handle it, we're actually going to apply some thickener. We're going to use a thickening agent for one of the batches so that we can minimize how many layers we need to apply in order to achieve that 3/8 of an inch or 1 centimeter of thickness that's recommended. It's really important to understand that the addition of the matrix thickener will slow the pot life and cure time of the Matrix Dryve. So when adding thickener, your working time and your cure time will be prolonged. We're going to add some extra accelerator to the batch that we're mixing the thickener in. And if we follow the instructions in the technical bulletin here, it shows that by adding 1.5% of the thickener to the mix, we're going to need to add 7 parts of accelerator to obtain a 4-minute working time from the material. You'll also notice there's a note that if you exceed 7 parts of accelerator, you will overload the material and it will thin out again. So it will render the thickener useless. I'm going to dispense the powder first, again using the gram scale, and dispense the water content for this batch as well. The accelerator is now added into the water immediately, so we don't have to add that separately. These 3 components are now blended together using a variable speed drill with the paddle mixer. And then we can add the thickener, again using a gram scale to be very exact. Once the thickener is added, we can go ahead and mix the components together. For the third and thickened layer, we're going to be using 400 grams of the matrix powder, 108 grams of water, 28 grams of the accelerator. Remember, we upped that quantity to 7%, and 6 grams of the matrix thickener. Here you can see the comparison between the unthickened material on the left versus the thickened Matrix Dryve on the right. You can clearly tell that the consistency of the material has changed and that the material on the left is a lot more liquid versus the material on the right that's been thickened. This will minimize the amounts of layers needed to acquire the recommended thickness of 3/8 of an inch or 1 centimeter. The material is again poured into the mold and the rotational casting process continues. So we're going to continue to spin the mold, again bringing that material right up to the edge, spilling some of it out, and then continue to spin the mold in a 360-degree fashion. Again, this is a little bit speeded up so we can get through the entire step much faster. And once again, I'm setting the mold up so that any of the liquid can make its way out. The material is now allowed a partial cure for 20 minutes. Now, to further strengthen our hollow casting, we're going to be using the Matrix chopped glass. And here's what that material looks like. These are chopped glass fibers that can be used either in reinforcement of gypsums or the reinforcement of concrete products. The glass fibers can be added anywhere from 3 to 12% of the total weight of the mix that you're using. For best results, we recommend 6% of the chopped glass fibers should be used. Now, just like we did on previous layers, we're going to dispense the powder. We're also going to dispense the chopped glass fibers, as well as the water for the mix that we're making. This fourth layer is going to incorporate the glass fibers to make our casting much, much stronger. Now that I weighted out all my components to the batch that we're mixing, I can go ahead and again use the variable speed drill with a paddle mixer to mix the components together. Now remember again, when you're mixing powders and liquids together, to always add the powder into the liquid, sift it in as you're mixing it. Again, this will prevent any of the material, the powder, from clumping up. Now, you can also wear a dust mask to prevent breathing in any of the powder dust as well. And once again here, we're adding the glass fibers to the Dryve that's already been mixed. And note that I'm adding the glass fibers by mixing them in with a mixing stick. I'm doing that so that I don't break the fibers by using a mechanical mixer. The fourth layer of our hollow cast project will receive 400 grams of matrix powder, 108 grams of water, 6 grams of the accelerator, and 24 grams of matrix glass. The material is now poured into our mold, and you can see that I'm brushing some of that up against the opening of the mold. Make sure that it stays there. It holds very well a vertical surface, and then once the material is in there, I'm going to spin that around and continue the rotational casting process, making sure that the material makes its way all the way around inside. And just peeking inside a mold like this gives me a much better idea as far as where the material is traveling to and where it needs to be. So you can then hold the mold in a very specific way. Once the material has stopped moving and you have a thorough coating of material on the entire inside of the mold, we can go ahead and set the mold upside down to allow any of the excess material to make its way out of the mold and not create a large mass on the inside of our casting. This material is now allowed a partial cure for 20 minutes. In the meantime, we can go ahead and prepare a melamine board with some sonite wax. We're going to simply put some sonite wax on the melamine board. This is to cap the casting itself, the mold, from the bottom. I'll show you that in a second. In the meantime, we can go ahead and mix another batch just like we did previously. And this batch will have no glass fibers in it. Just like the first and second layer, we're going to dispense same quantity of material for this fifth and final layer. We're dispensing 400 grams of the matrix powder, 108 grams of water, and 6 grams of the matrix accelerator. The three components are mixed thoroughly before being poured into the mold. And once it's mixed, we're going to pour it inside the mold and we're going to rotationally cast the material again. Again, making sure that the glass fibers inside are fully encapsulated in the Dryve material. We want to make sure that the entire inside of the mold is covered with a fresh layer of material. We also want to keep in mind the working time of the material and not let it solidify and set up fully in the mold. Now I'm going to put that melamine board at the bottom of our mold, and here again you can see how useful it is to have the top of the head be a foot for the mold so that you can stand the mold on its own upside down and work the material. By clamping down the board to the bottom of the mold, we can now flip the mold over and allow the material to make its way down and basically seal the opening of the casting so that we have a flat bottom. If we don't clamp down this board to the support shell, the material will leak out of the mold, creating not only a mess on your hands, but also a failed casting. Now I can go ahead and clean my tools and put some of the materials away while the material cures for 60 minutes before demolding. After 60 minutes, we can go ahead and demold our casting here. The clamps are put away. We can inspect the bottom here, nice and flat and hollow, very good. Happy with that. And I can go ahead and remove the rubber straps that are holding our two-part support shell together. And then we're going to retrieve our casting. The second half is removed. You can see the separation line in the back, the seam line or cut line, so to say. And one thing you can notice here that the flashing on the back is very, very minimal. So it's going to give us very minimal post-finishing efforts. And here we can see the casting front. The face came out very good. There's no air bubbles. And I'm really happy how this came out. And here you can see into the mold. And just so you see how lightweight this is, it's easy to toss around. It's hollow, knock on it, but very strong and durable. Once the material is cured, the Matrix Dryve can easily be sanded down using regular sanding paper, or as I'm using here, a sanding pad. Use a fine grit for small blemishes, while larger blemishes can be easily removed with a coarser sandpaper. And here you can see our final casting up close again. You can see that the casting material has captured the detail of the mold perfectly, and you can see how easy it is to make hollow reproductions using the Matrix Dryve. As you can see here in our casting, the hollow casting is very lightweight and can easily be handled and even tossed in the air, while being exceptionally strong that it will withstand the beating with a mallet. As you can see, I'm repetitively hitting on the casting without breaking it. The benefit of making hollow castings is that it uses a lot less material than solid castings would. For example, here, the same sculpture will weigh 17 pounds if cast in solid, whereby a hollow piece of this same exact sculpture will weigh about 7 pounds. Quite a drastic difference in weight. The benefit of casting hollow sculptures versus solid is very obvious. We're using less material, and we were able to save 60% of the cost by making our casting hollow and not solid. The trade-off for saving material by doing hollow castings is the fact that you spend more labor and time versus casting the solid pieces. Now, if you like this project and you would like some materials to give your own projects a go, you can visit any one of our distributors around the world. So, and there you have it. A step-by-step procedure on how I use the Matrix Dryve to create hollow yet strong and lightweight castings using the Matrix Dryve in a Rebound 25 brush-on mold. Now, let's just take a quick look at our project goals. We were able to create a strong and hollow yet lightweight casting using the Matrix Dryve. We also showed you how to use an alternative to resin to create your hollow castings, as well as how to reduce the cost of your project by creating hollow castings versus solid ones. Now, if you have an idea about what we should do next, please let us know down in the comments below. And if you like this video, hit the thumbs up button. To keep up with our latest mold making, casting, and other videos, remember to subscribe.